Hello students, welcome to Vyas Edification Kota. In this series of NCERT discussion, we'll continue further with Mathematics class 12th. The chapter that we're dealing with is integrals, and now is the turn of exercise 7.4. Now this particular exercise is based on some algebraic integrals of the form 1 upon x square minus a square, 1 upon x square plus a square, 1 upon a square minus x square, and similarly their under root forms. Along with that, we can also solve linear upon quadratic or linear upon root quadratic. All kinds of those things can also be solved over here, right? So along with the questions, we'll be seeing the formulae, right, and the methods which we want to use over here. So coverage of theory will go alongside the problems. That's what we'll be doing over here, right? So let's begin the first question, which says, okay, you have 3x square over x power 6 plus 1. Now this is not a direct question, but this is an indirect one, and the first thing that you can observe over here is, okay, this is x square, which is actually the derivative of something called x power 3 over here, right? Yes. So I observe that I have 3x square over x power 3 square plus 1, because I am interested in a quadratic in the denominator, right? A quadratic in the denominator can be solved easily. This exercise is based on that, but in future also when you encounter such questions, a quadratic in the denominator, only a quadratic in the denominator can be solved easily, right? By direct formulae. That is the aim. So let x power 3 is equal to t, and that tells me that 3x square dx is equal to dt. Therefore, I becomes equal to 3x square dx, which is dt, upon x cube, which is t, this is t square plus 1. Okay, this is a direct formula. This is equal to tan inverse t plus constant of integration, right? Okay, and it finally leads to tan inverse of t. T is x power 3 plus c. Now this is the formula that we have used over here, and that gives me the final answer. Integration occurs at this stage. Substitution obviously is a part of integration only, but the formula that we have used over here is integral of 1 upon x square plus 1 dx is simply tan inverse x plus c. A more generalized version would be integral of dx upon x square plus a square. This is equal to what? This is equal to 1 upon a tan inverse x upon a plus constant. This is a more generalized version when you have a square along with x square, right? Instead of x, if you have a linear function, linear polynomial of x, like instead of x, if you have px plus q square plus a square, the answer would be 1 upon a tan inverse px plus q upon a, and you also have to divide by a p over here, right? That is something which you have seen, right? If instead of in the formula, if instead of x you have a linear polynomial of x, then at max the one and most important thing that you want to do in the end is dividing by that coefficient of x, right? So this particular formula is useful over here, yes. And along with that, we have solved the solution. We have solved this particular question using that particular formula along with substitution, right? The next question, this, okay, what I observe over here, that this I is equal to integral 1 upon under root of, this is actually 2x, 4x square is 2x square plus 1 is 1 square, right? This is the form that I have. Okay, now this is similar to 1 upon root quadratic, right? 1 upon root quadratic, we have x square plus a square dx integral. This is one of the versions, and this is equal to log modulus x plus under root of x square plus a square plus constant. There is another formula which looks similar to this, where you have x square minus a square. Instead of x square plus a square, you have x square minus a square, and the value will be equal to, when you have both the things in root, x plus under root of x square minus a square modulus plus constant. These can be solved with the help of substitution, right? X can be proved with the help of substitution. X can be taken as a tan theta over here, x can be taken as a sec theta over here for proving these results. But there's another one. When you have root in the denominator, you can have a square minus x square as the quadratic as well. And in such cases, the result will be sine inverse x by a plus c. This is the other formula. So these are some formulae which you should memorize. X square plus a square, x square minus a square, and a square minus x square in the under root. So this is all forms of 1 upon root quadratic. 1 upon root quadratic. These are the forms. Here you have x square, something linear polynomial of x. So you can read it as 1 upon x square plus a square. This is the version that we are interested in. Log modulus of, what you'll get is, instead of x you have a 2x plus under root of 2x square plus 1 square. And this is the final formula, but you have to divide by the coefficient of x, which is 2, plus a constant term. This is equal to 1 by 2 log modulus 2x plus under root of 4x square plus 1 plus constant is what remains over here. This is the final answer. Yes, using this formula. A slight modification, that is, instead of x, if you have a linear polynomial of x, px plus q, this becomes px plus q, this becomes px plus q, and you divide by p, then. Is that all? Yes, that's all in this question. In the third question we have, you have linear polynomial of x squared plus 1 square again. So this is 1 upon root quadratic. So I'll write the formula again. This is x square plus a square dx, which is equal to log modulus x plus under root of x square plus a square plus constant. Instead of x, if you have px plus q, that is linear polynomial of x, at the end you have to replace x by px plus q, x by px plus q, and in the end you divide by p. So I is equal to integral of this dx over, what is this? This is 2 minus x square plus 1 and under root. By the way, this is 2 minus x square. Can I also write it as x minus 2 square? Will that make any difference? No, that will not make much of a difference, right? I can write it as x minus 2 square over here only, or I can solve it like this. If I solve it like this, what will I get? This will be equal to log modulus x plus under root of x square plus a square. Since this is 1 square, right? This 1 square becomes 1. Modulus plus c, but you missed out on one thing. What is that one thing? You need to divide by the coefficient of x, which is minus 1. This is what you missed out on. Don't miss out on that. This is minus of log modulus 2 minus x plus under root of 2 minus x square plus 1 plus constant, right? This is what you get. That's the final answer. Another way of dealing with the same thing, because I have explained you this, you can solve it like this. But if you wanted to solve as per maybe the NCERT people, what do? They will ask you to substitute 2 minus x as t. They will write minus dx is equal to dt, and therefore I will become equal to integral of minus dt upon root of t square plus 1. At this stage they will apply the formula, giving you the same thing, log modulus t plus under root of t square plus 1 plus constant. This is what you get, right? And at the end you will substitute t is equal to 2 minus x, and you will get the same thing, right? This is the version. This is the question number 3rd. In the 4th question we have 9 minus 25x square, okay, and this one will convert in terms of sine inverse, right? This is a square minus x square, okay. So I is equal to integral of dx upon under root of, this is 3 square minus 5x squared. Yes, do you observe this? Yes. And I'll use the result for a square minus x square dx. Integral is equal to sine inverse x by a plus c. Instead of x, if you have px plus q, that is a linear polynomial of x, this will become sine inverse px plus q upon a and divided by another p. We'll have to divide this expression by another p. And that's what will be happening over here. This is sine inverse x upon a, and you'll have to divide by this coefficient of x, which is 5 plus constant. This is actually 1 by 5 sine inverse 5x by 3 plus constant. That is the required answer for this question with the help of this formula. The fifth question says we have 1 plus 2 x power 4. Now x power 4 is actually square of what? This is square of x square. Yes. And the derivative of x square is present over there. What about those constants? We don't need to worry about the constants, right? We know that. We know that. So let's write I equals integral of 3x upon 1 plus, this is root 2 x square and its whole square dx. This cannot be handled like a linear expression, right? This is not a linear expression. So we'll use substitution. Let root 2 x square is equal to t. That tells me root 2 times 2x dx is equal to dt. Okay. Therefore, I is equal to integral of x dx can be replaced by, okay, there's a 3 dt upon 2 root 2 from here. In the denominator, you have 1 plus t square. Do you observe that? 1 plus t square, right? So that gives me I is equal to 3 upon 2 root 2 will come outside the integral. This is not impacting anything, right? And integral has dt upon, you have 1 plus t square, and this here is a standard formula, right? Okay, so we can apply that formula. 3 upon 2 root 2, this is tan inverse t plus a constant. 3 upon 2 root 2 remains as it is, yes. And this is tan inverse t. What is t here? T is root 2 x square plus constant. This is what you get. That is the required answer for this fifth question for us. Yes. In the sixth question, we have x square upon 1 minus x power 6. How do we handle this? Okay. This is square of something, right? This is square of x cube. And the derivative of x cube is present over there. Yes, that will help us. 1 minus x power 3 square dx. And we'll assume let x power 3 is equal to t. That tells me 3x square dx is equal to dt. Okay. So x square dx can be replaced by dt. Therefore, I becomes equal to, there will be 1 by 3 with dt. In the denominator, you will get 1 minus t square. Now comes once again another formula. That if you have 1 upon quadratic, if you have 1 upon quadratic in the denominator, so dx upon, we have already seen x square plus a square. There are two more results. X square minus a square is equal to what? This is 1 upon 2a log modulus x minus a upon x plus a plus constant. Okay. Although this is the only one that you should remember, but there's another version of this, which is a square minus x square, and there's no under root, mind you. There's no under root. This is over here, which is 1 by 2a, okay, log of modulus a plus x over a minus x. If you remember both, well and good. If you remember both, well and good. If not, then you should remember at least this one by heart. Remember this by heart, first of all. Memorize this like anything. This is log mod x minus a upon x plus a. What is happening over here? Simply multiplying with a minus, right? In the LHS, simply multiply with the minus on the right hand side. That minus, this multiplies with a minus, this also multiplies with a minus. That minus can go over here in power, and log x power minus 1 will be equal to log 1 by x. That will be the reciprocal of this. X plus a, x plus a. X minus a becomes a minus x. There's a modulus over there. Does it make any difference? No. That is how you get the second version with the help of this one. Right. So what do we have over here? We have 1 square minus t square, which is a square minus x square. This particular form. Yes. So the formula says this is 1 by 3, 1 by 2a log mod a plus x, which is 1 plus t, upon a minus x, which is 1 minus t plus constant. This is equal to 1 by 6 log mod 1 plus t upon 1 minus t, or t. Oh, we need to substitute that t as well, right? Let's use that substitution for t. Don't miss out on that t. This is x power 3 plus constant. That is my required answer. This is 1 plus x power 3 upon 1 minus x power 3 in the log 1 by 6 outside. And that's the final answer for the 6th question using these results. In the 7th question, you have x minus 1 upon under root of x square minus 1. How will we handle this one? Okay, in the denominator you have a simple thing, but in the numerator you have a linear expression, right? So this is actually of the form linear upon root quadratic, or which is actually px plus q upon under root of ax square plus bx plus c form. And these type of integrals where you have the numerator and under root of quadratic in the denominator can be written as numerator has to be expressed in terms of derivative of the d by dx of denominator, derivative of denominator plus some constant term. Finding the values of a and b is the key over here. Now writing it in this particular form, or you can actually say we are writing L as that linear term as a times d by dx of that quadratic plus b. You can say this, or px plus q is written as a times derivative of this plus another constant b, right? Important thing is, if you can find a and b, this is always equal to this, this is always equal to this, this is always true. So this equivalent to this is actually an identity, right, which is true for all values of x. We can easily find a and b. Once we find a and b, we can separate that single integral as sum of two integrals, in terms of two integrals, right? And those two integrals will be easily solvable. How? This becomes pretty easy. Okay, you have the quadratic in the denominator and you have the derivative of the quadratic in the numerator. So quadratic can be substituted as t and easily solved. In the second, you will have simply quadratic in the denominator, and thus can be solved with standard formulae, right? Standard formulae. So we'll use that idea. I is equal to integral of x minus 1 upon under root of x square minus 1 dx. Okay, this is the denominator. This is a quadratic in the denominator. This is a numerator. So let x minus 1, we'll use the form x minus 1 is equal to a times derivative of this x square minus 1 plus some other constant b. This tells me, okay, x minus 1 is always equal to a times, this is 2x plus b. Is it not? Yes, please observe this. Okay. And since this is always equal to this, compare. Simply compare coefficients of x and constant term. Compare coefficient of x and the constant term. Therefore, coefficient of x is 2a and here it is 1. 1 is equal to 2a. Minus 1, the constant term is equal to b. Right or not? So that tells me a is equal to 1 by 2 and this tells me b equals minus 1. Okay. Once you find the values of a and b, that's one part of the solution. That's one part of solution, and you have used this idea to write it as this, right? Let me get rid of this thing and then we'll continue further. The next step says that we can substitute these values over here. Therefore, I is equal to integral of x minus 1 has been written as a times 2x. A is half. Half times 2x. Okay. Plus b, which is minus 1 upon this under root of x square minus 1 dx. These will be written separately, 1 by 2 integral 2x upon under root of x square minus 1 dx minus integral of 1 upon under root x square minus 1 dx. This can be solved with a simple substitution now. This part over here, let x square minus 1 is equal to t, which tells me, okay, 2x dx is equal to dt. We have planned it in such a manner that the derivative of the denominator comes in the numerator. And this here is a standard formula. What is that? 1 upon x square minus a square in the under root is equal to log mod x plus under root of x square minus a square. That's simple thing, right? So using this substitution, this becomes 1 by 2 integral of 2x dx is dt upon under root of t plus, this here is simple. Okay, this is not a plus, this is a minus over here. Minus, this is log modulus, you can write that directly, right? X square minus a square, x plus under root of x square minus a square modulus. Okay, and this integral is remaining. After that, we'll add that constant of integration. This 1 by 2 is simple. This is t power minus 1 by 2. Okay, and what is that equal to? T power 1 by 2 upon 1 by 2, that becomes 2. That becomes, okay, from the denominator, if you have 1 by 2, that will come in the numerator. This becomes 2. And t power 1 by 2 in the numerator. Okay, minus, this is log modulus of x plus under root of x square minus 1 and plus a constant of integration. Now, this 1 by 2 and 2 gets cancelled. T under root of t is actually under root of x square minus 1. That comes over here, minus log modulus x plus under root of x square minus 1 plus constant is the final answer for this complete question, as you can see. That's the final answer? Yes. That's all that you have in this 7th question. In the 8th question, you have x power 6 plus a power 6 in the denominator. Oh, this is square of x cube and the derivative is present over there. Yes, that's what you'll use. That's what you'll use. So let x power 3 is equal to t, and that tells me 3x square dx is equal to dt. Okay. I, which was equal to x square upon under root of x power 3 square plus a power 6 dx becomes equal to what? This becomes equal to x square dx is 1 by 3 times dt, and x power 3 is t square plus, this is, what is this? This is a power 3 squared in the under root, right? There's an under root over here. And what next? This is x square plus a square in the under root. Yes, this is a direct formula which says 1 by 3 log modulus of x plus under root of x square plus a square, which is 2 square plus a power 6 plus a constant, and this becomes 1 by 3 is okay, log of modulus t. What is t? X power 3 plus under root of x power 6 plus a power 6 plus a constant. This is what you get. And yes, that's the final answer for this question over here. Question number 9 says sec square x upon under root of tan square x plus 4. How do we handle this? You can observe that the derivative of tan x is present in the numerator. Yes, and that is the important thing to observe over here. So if you observe, I is equal to integral of sec square x upon under root of tan square x plus 4 dx, and the substitution that we'll use is tan x is equal to t, which tells me, okay, sec square x dx will be equal to dt. Therefore, I becomes equal to integral of dt upon under root of t square plus 4. Now this is a standard result. Under root of x square plus a square in the denominator will tell me that I equals ln mod x plus, that is t plus under root of t square plus 4 plus constant of integration. What is this t? This t is nothing but tan x under root of tan square x plus 4 and its modulus plus c. That's the required answer. The formula that we've used over here, let me write that formula. Under root of x square plus a square dx integral is equal to ln mod x plus under root of x square plus a square plus constant of integration. That's what you have. That's the formula that we have used for writing this integral from there directly. Yes, and that's all in this 9th question. The 10th question says we have 1 upon root quadratic again, and that quadratic can be written as a perfect square. Write it as a perfect square first of all. 1 upon under root of x square plus 2x plus 2. Okay, integral of this with respect to x. This is what you are interested in. This is under root of x plus 1 square plus 1. Please observe, x square plus 2x plus 1 will be this, plus extra term 1 will be here. This can be written as this. Once we write this as this, we have x square plus a square form, right? And this can directly be written as ln mod, instead of x you have x plus 1 plus constant of integration. At the end you only need to divide by the coefficient of x, that is 1 over here, and division by 1 will not make any difference. This is equal to ln of modulus x plus 1 plus under root of, this becomes x square plus 2x plus 2 modulus plus constant of integration, and that is my required answer for this 10th question, as you can see over here. The 11th question says you have 1 upon quadratic over here. Okay, now let's try to simplify this 9x square plus 6x plus 5 first. 9x square plus 6x plus 5. For completing the perfect square, what we can do is we can take out 9 common from the first two terms. I get x square plus 6 by 9, which is 2 by 3, x plus 5 is also there. Yes. Okay, we can take that 9 common from this 5 term as well. Okay, so what we'll do is, let's write it in this manner so that that 9 can be taken out directly. This is 5 by 9 over here. Right. This simplifies to 9 is okay. And in the bracket, what do you get? X plus half of this, which is 1 by 3 squared. Okay. So x squared 2 by 3x have been taken care of. Extra term will be 1 by 3 square, which is 1 by 9. You have to subtract 1 by 9 plus 5 by 9 is already here. Okay. And this becomes 9 times. In the bracket, you have x plus 1 by 3 square plus 4 by 9. Now 4 by 9 is 2 by 3 whole square. That's what you observe, right? Therefore, integral I is equal to what? Integral I will be equal to dx upon, you've taken out a 9 common, yes, and what remains is x plus 1 by 3 square plus 4 by 9 in the bracket. And this is 1 upon x square plus a square form, right? This 9 will come out, okay, 1 by 9 goes outside, and this is 1 upon x square plus a square, x square plus a square. 1 upon x square plus a square can be handled with this version of the formula. 1 upon x square plus a square dx integral is equal to 1 by a tan inverse x by a plus constant of integration. This is a formula. Instead of x, we can have a linear polynomial of x, px plus q, and in case we have px plus q over here, we will have to divide by p, and something of similar sort may be done over here. Instead of x, we have x plus 1 by 3. So this becomes tan inverse x plus 1 by 3 upon this 2 by 3. This is square of 2 by 3, right? And we also had 1 by a over here. 1 by 2 by 3 should come over here. A is 2 by 3. Right? Comparing with that formula, this is what you get. This becomes 18, 3 by 18 is 1 by 6 tan inverse. This becomes 3x plus 1 multiplying by 3 in the numerator and denominator. This is what you get. Okay, there was a constant of integration as well, yes. And that is my final answer for this particular question over here. With that formula, I have solved this one. Oh, you were supposed to divide by the coefficient of x, which is 1. Division by 1 will not impact much, right? That's all in this 11th question. The 12th question has 7 minus 6x minus x square, 1 upon root quadratic form. And how do we handle this one? So 1 upon root quadratic. Let's take a look at that 7 minus 6x minus x square again. What I'll do is, I'll take out a minus common and I'll write x square plus 6x minus 7 first of all. And now I'll try to convert this into a perfect square. So this becomes x plus 3 squared. Okay, x plus half of 6 is 3. The extra term will be 3 square. We'll have to subtract 3 square, that is 9, minus 7 is already there. This makes it, this is 16 with a minus, that will become 16 minus x plus 3 square. This is the form that we are looking at. This is the required form, converting into perfect square. So I is integral of dx upon under root of this, which is equal to 16 minus x minus 3 square. Okay. And now using one formula. What is that formula? 1 upon under root of a square minus x square dx. This integral is equal to what? This integral is sine inverse x by a plus constant, right? Using this version of the formula, for 1 upon root quadratic, what do we get? Therefore, I is equal to sine inverse x by a, and what is x? X is, as you can see, x minus 3 upon a. What is a? You can observe over here. Okay, just a minute. This is x plus 3. This is not x minus 3. This is x plus 3. This should also be x plus 3. And a, as you can observe, is, since a square is 16, a will be equal to 4. This is what I get. Sine inverse x plus 3 upon 4 plus a constant of integration. We can divide by the coefficient of x, which is 1, but that's okay. And this is my correct answer for this particular question over here. In the 13th question, we have x minus 1 times x minus 2. Okay. How do we handle this one? So, let's try to convert that once again. In the denominator, we have root quadratics. Let's convert that quadratic into a perfect square. So, that quadratic is x minus 1, x minus 2, which is actually x square minus 3x plus 2. Okay, and this can be converted as x minus 3 by 2. Half of 3, that is the coefficient of x squared, and this 3 by 2 square will be subtracted. Plus 2 is already there. This simplifies to what? This is 9 by 4 with a minus. Okay, this becomes 16 minus 9, which is 7 by 4. Sorry, not 16. This is actually 4 times 2, 8. 8 minus 9 by 4. So, this becomes x minus 3 by 2 squared minus 1 by 4 is what will remain, right? Minus 9 plus 8 is minus 1 by 4. This is what you get. So, I can write, therefore, I is equal to integral of 1 upon under root of this form of that expression, x minus 3 whole square plus, sorry, x minus 3 by 2 square minus 1 by 2 square. This is what you have, right? If you observe this carefully, the next thing that you want to do is, we'll use the formula, and what formula I'm talking about? I'm talking about this one, integral of 1 upon root x square minus a square. This will convert to log modulus of x plus under root of x square minus a square plus constant. This is what you have, right? This is what you have. So, this will be equal to log modulus x minus 3 by 2. Instead of x, we have x minus 3 by 2. Okay. Plus under root of x minus 3 by 2 square minus 1 by 2 square, x square minus a square modulus plus constant. This is what you have using this version. Instead of x, we have a linear expression of x, so we'll divide by the coefficient of x. Coefficient of x is 1, we divide by 1. This is pretty simple. This simplifies to log of modulus x minus 3 by 2 plus under root of this whole expression. Now, what is this whole expression equal to? Oh, this was nothing but this only. Yes. So, I can write it as x minus 1, x minus 2 modulus plus constant term, and that is the required answer. As you can see, that's the required answer using this and this. These are two important things which I have used over here. One is completing the square, the other is the formula, right? If you know these two things, then solving this question is a cakewalk. That's the 13th question for us. Let's take a look at the next one. The 14th question once again is a 1 upon root quadratic form. Okay. And since coefficient of x square is negative, okay, this will convert into a square minus x square and the under root, right? So, that will go to sine inverse x by a, something which we know. Okay. So, 8 plus 3x minus x square is equal to what? This is minus of x square minus 3x minus 8. First of all, minus is okay. This becomes x minus half of 3, which is 3 by 2 squared. Then you subtract this square, which is 9 by 4. You already have a minus 8 over here. 4 into 8 is 32. 32 and 9 will make it 41. So, this is 41 by 4 with a minus. This becomes 41 by 4 and minus of x minus 3 by 2 whole square. This is what I have, first thing. This is what I have, right? That's the expression. So, therefore, integral I is equal to what? Dx upon root of this. 41 by 4 is root 41 by 2 and its square, right? We are interested in a square minus x minus 3 by 2 square. This is what you are interested in, right? Root 41 by 2 square minus x minus 3 by 2 whole square, and this is of the form a square minus x square under root in the denominator. The integral is equal to sine inverse x by a plus constant. This is what we'll be applying, right? This is what we'll apply next. So where does that take me? This is sine inverse x minus 3 by 2 upon a, which is root 41 by 2. This is what you have, plus constant term. This is what you have. Sine inverse x upon a is what I am getting. We'll have to divide by the coefficient of x, which is 1. So division by x is not an issue. This is what I'll get. Sine inverse, this becomes 2x minus 3 upon root 41. Okay, and plus constant term. That's my required answer for this particular question over here. That's the answer. Yes, that's the answer for this question. The 15th question says, okay, you have to integrate 1 upon root of x minus a, x minus b. Once again, we have 1 upon root quadratic. So we'll begin with that quadratic. The quadratic is x minus a, x minus b. Okay, and we'll have to convert this into a perfect square first of all. Yes, this is actually equal to x square minus a plus b x plus ab. Can you observe that? Yes. Okay, and what does this simplify into further? This is x minus this a plus b by 2. Half of this is what we'll require. Square of this, okay, and subtract the square of this, a plus b by 2 square plus ab is already there. And can we simplify this whole expression? Yes. This is a plus b whole square and plus 4ab, minus 4ab actually. Okay, so this is x minus a plus b by 2, its square, and this actually becomes, we take out a minus common, a plus b whole square minus 4ab, that is a minus b whole square upon 2 square actually, this becomes this. Okay, that expression simplifies to this now. Once we have this much, once we are clear with this much, therefore I can be written easily. Therefore I is equal to integral of dx upon under root of this whole expression. What is that? X minus a plus b by 2 square, okay, minus a minus b by 2 square. And this is of the form x square minus a square. This is similar to x square minus a square. And what is the formula for? 1 upon under root of x square minus a square dx. This integral is equal to what? This goes into log plus constant. This is the formula that we need. And using that formula, instead of x, we have a linear expression of x, linear polynomial of x. So this becomes ln mod x minus a plus b by 2 plus under root of this whole expression. And what is this expression equal to? This expression is equal to this only. So x minus a, x minus b modulus plus constant. That's what you have, and yes, that's the required answer for this question over here. In general, obviously, some people would ask you to remember this. What I have done is x minus the average, the mean of a and b, and plus that same expression in the root will come over here, and that's the integral, right? So if you have x minus 1, x minus 2, you know what to do. If similarly you have other things, you know what to do, right? In such kinds of question, this is the final answer of this particular question, and similar question can be solved easily, right? The 16th question says we have a linear upon root quadratic form. Yes. Now this is interesting. Linear upon root quadratic, that linear has to be simplified somewhere. So what we'll do is this 4x plus 1 is equal to what? This is equal to, this should be written in the form of derivative of this denominator, a times the derivative of this, which is 4x plus 1 and plus b. Okay, and the next thing that we want to do is compare. Comparing the coefficient of x and constant term. Coefficient of x implies that 4a will be equal to 4. This tells me, okay, a will be equal to 1. Okay, since this is an identity, this has to be true always. Okay, comparing the constant term implies 1 equals a plus b over here, and that tells me, okay, b will be equal to what? This will be equal to 0. Oh, pretty interesting. There's no second term over here, right? There's only one term, that's the first term. Since a is equal to 1, therefore I is equal to integral of 4x plus 1 upon root of 2x square plus x minus 3 dx. And what we can do is let 2x square plus x minus 3 equals t, that makes it 4x plus 1 times dx is equal to dt. This is what I get. This tells me that I will be equal to what? 4x plus 1 times dx is dt upon under root of this whole expression, which is t. And what's the integral of t power minus half? That is 2 root t plus a constant, right? This is what you get. T power minus half will be actually t power half upon half, that becomes this, and this converts to 2 under root of 2x square plus x minus 3 plus constant. That is my required answer for this particular question, 16th over here. Yes. Had there been another term, that would be equivalent, that would imply that we have another 1 upon root quadratic, and that could be solved using approaches which you have just seen in the past few questions, and again we'll be seeing those approaches in the next few questions. Right, this is 16th question for us, and that's a complete solution of this 16th question. Question number 17 says, okay, integrate x plus 2 upon under root of x square minus 1. Now once again, this is linear upon root quadratic, so we'll have to write that linear in some particular form, right? That x plus 2 has to be written as a times the derivative of this 2x x square minus 1, which is 2x plus some other b. And since this is an identity, so compare the coefficient of x. Simple idea is compare the coefficient of x. 1 is equal to 2a, that tells me, okay, a will be equal to 1 by 2, and 2 is equal to b, that gives me the value of b, this gives me the value of a, right? That's the first thing that you note. Once you note this, therefore I is equal to a, which is 1 by 2 times integral of 2x upon x square minus 1 dx. This is the first integral that we are interested in. The next is b plus 2 times integral of 1 upon under root of x square minus 1 dx. This is the second integral that we are interested in, right? So let's call this half I1 plus 2 I2, and we'll solve I1 and I2 separately. Now for solving I1, it is integral of 2x upon root of x square minus 1 dx. You can observe that x square minus 1 can be substituted as t. That gives me 2x dx is equal to dt. Actually, this has been planned in such a manner over here that the derivative of denominator comes over there, right? This has been planned in such a manner. Therefore, this is equal to integral dt upon root t. The integral will be 2 root t plus some constant of integration. Let's call it c1, right? And this becomes 2 under root of x square minus 1 plus c1. That's one thing. What about I2? I2 is equal to integral of 1 upon x square minus 1 under root dx, and this is a direct formula, right? This is x square minus a square in the under root. That makes it ln mod x plus under root of x square minus 1 modulus plus some other constant of integration c2. So once we have I1 and once we have found I1 and I2, now we can write I in terms of these. Therefore, I will be equal to half of I1, half times that. So that is under root of x square minus 1 plus c1 by 2. That's what you have. Plus 2 times I2, okay. So plus 2 times ln mod x plus under root of x square minus 1 plus 2 c2. This and this here are nothing but constants of integration. They can be combined into a single constant, and what you get is under root of x square minus 1, this is the first term, plus you have another term 2 times ln mod of x plus under root of x square minus 1 plus some constant of integration. That's the required answer for this question 17th over here. In the 18th question, we have linear upon quadratic, okay, and once again the approach that we want to follow over here is write that linear as sum of one term which is having derivative of the denominator and another term which is a constant. So this numerator 5x minus 2 will be written as a times derivative of denominator, which is 6x plus 2. Can you observe? 6x plus 2 plus b. And since this is true for all values of x, one of the ideas is you can substitute some value of x to get a and b. Let's say form two equations to get a and b, or we can simply compare the coefficients of x and constant term. From the coefficient of x, 6a is equal to 5. Okay, coefficient of x is 6a, that is 5, so that gives me a is equal to 5 by 6. That's the first thing. What next? Constant term minus 2 is equal to 2a plus b. Okay, and that tells me since a is 5 by 6, this is 2 times 5 by 6, which is 5 by 3. So b is equal to minus 2 minus 5 by 3. Okay, this is minus 11 by 6. That's what you get. Minus 11 by 3, not 11 by 6. It's minus 11 by 3. Right? Let's check that value again. This is minus 11 by 3. Okay. And 5 by 3. 5 by 3 minus 11 by 3 will be minus 6 by 3, which is minus 2. That's okay, right? So a and b have been found. Okay. Therefore, the integral will be equal to what? A times 5 by 6 times integral of this derivative 6x plus 2 upon that 1 plus 2x plus 3x square dx minus 11 by 3, that is the value of b, plus another integral dx upon, this is b, right, constant, 1 plus 2x plus 3x square. We have written that complete integral as sum of two integrals in this manner. So this is 5 by 6 I1 minus 11 by 3 I2. Our target is to find I1 and I2 separately. Once we find I1 and I2, then we can write that expression, complete that expression by writing the values of I1 and I2. So I1 is pretty simple. This is 6x plus 2 upon 1 plus 2x plus 3x square dx. The important thing over here is this 1 plus 2x plus 3x square can be written as t, and this tells me x, okay, this tells me 6x plus 2 times dx will be equal to dt. And we have actually planned using that idea, right? Derivative of the denominator is with a over here. That 6x plus 2 is nothing but the derivative of denominator, yes. So this becomes, okay, dt upon t integral, this is log mod t plus constant, which is log of mod 1 plus 2x plus 3x square plus c1, let's call this constant c1. This is I1 for us. Okay, once we have found I1, can we also find I2? Yes, we can find I2. Now for I2, we need this integral, and for finding this integral, we need to convert this into a perfect square first of all. Right, this is 1 upon quadratic form, we'll have to convert this into a perfect square. So let's focus on that particular part first. We have 3x square plus 2x plus 1. We can take out a 3 common, this becomes x square plus 2 by 3 plus 1 by 3. Is that okay? Yes, that looks simple. That looks simple. And what next? So this can further be written as 3 is okay. This is x plus half of 2 by, this is 2 by 3 x, mind you, right? Half of 2 by 3 is 1 by 3 squared, okay, and 1 by 3 square will be subtracted. This is 1 by 9 plus 1 by 3 is already there. Okay, so this is 3 by 9, this is 1 by 9, this subtracted will become 2 by 9. So this is 3 times in the bracket x plus 1 by 3 squared and plus 2 by 9, which is root 2 by 3 square. That's the expression that I have. For I2, that's the expression that I have, that's the expression that I need. Once I have that expression, what I can do is, I can easily write this integral now using a formula. So I2 over here is this. Let's observe, I2 over here is this expression, and what does that give me? Integral of this I2 will become integral of dx upon 3 in the denominator will come out, okay, and what remains is x plus 1 by 3 squared plus root 2 by 3 square. And this is similar to x square plus a square, right? 1 upon x square plus a square, that converts to 1 upon a tan inverse x by a, okay. This 1 by 3 is outside. 1 by a means the reciprocal of this will be 3 by root 2. tan inverse x by a is what I get, and x plus 1 by 3 upon root 2 by 3 multiply by 3, this becomes a 3x plus 1 upon root 2 plus constant c2. That's the other constant that you need. This 3 cancels with this 3, and this is I2 for us. This here is I2. Once you have found I1 and I2, the next thing that you want to write is value of I from there. Therefore, I will be equal to what? 5 by 6 times I1. Now, this is 5 by 6 times I1. 5 by 6 log of modulus 1 plus 2x plus 3x square and minus 11 by 3 times this I2. So, minus 11 by 3 root 2 tan inverse 3x plus 1 upon root 2 plus, what do we have? We have this constant multiplied by 5 by 6, this constant multiplied by minus 11 by 3, which will convert into a new constant c, and yes, that is the required answer for this complete question over here. Now, in all such questions of linear upon quadratic, linear upon root quadratic form, you'll have to follow similar steps. First you write this expression. You find the values of a and b by comparing the coefficients. You write in terms of two integrals I1 and I2. Then you solve I1, you solve I2, and write the final I in terms of I1 and I2 there. Right? That's the approach that you'll follow in all such questions. Right? So this is the 18th question for us. Let me get aside. You can take a look at the complete solution over here, and we'll move on to the next one after this. The 19th question says you have 6x plus 7, that is a linear, upon root of x minus 5, x minus 4. Once again, root of quadratic. So how do we handle this? The way to handle this is, once again, in the denominator you have x. Let me write this expression first of all in another form, that is, this is 6x plus 7 is okay, and in the denominator you have x square minus 9x plus 20. Do you observe this? Yes. There is x square minus 9x plus 20, and after this, I'll start from here, and let me write the numerator, that is 6x plus 7 as a times the derivative of this, which is 2x minus 9, derivative of this denominator quadratic, plus some other constant b, right? This is what you have, and this is always equal to this, therefore we can compare coefficients. Comparing tells me that 6 will be equal to 2a or a will be equal to 3. This is the first thing that I observe. Yes. What else? 7, that is a constant term, will be equal to minus 9a plus b. That tells me b will be equal to 7 plus 9 times a. 9 times a is 9 times 3, 27. 27 plus 7 is 34. This is the value of b. This looks pretty big, but this is what you have, right? Plus 34. Yes, plus 34, right. So therefore I is equal to a times 2x minus 9 upon this, which is 3 times integral of 2x minus 9 upon under root of x square minus 9x plus 20 dx, and plus b, which is 34 times integral of, this numerator will be 34 times dx upon under root of that whole expression, which is x square minus 9x plus 20. This is what we have. This is what we have, right? Now, integral of this has to be found. Integral of this has to be found, and then we get a final answer. This is actually 3 times I1 plus 34 times I2. Okay, and our target is to find I1 and I2. Our target is to find I1 and I2. Let's try to find I1 first. I1 is pretty simple, looking pretty simple, yes. This is nothing but 2x minus 9 upon x square minus 9x plus 20. So we can take x square minus 9x plus 20 as t. This will be a derivative of this. So this actually becomes dt upon root t integral, which is 2 root t plus c1. This becomes 2 root of x square minus 9x plus 20 plus c1. You can write it as this, c1, right? This is I1 for us. Okay, is that all in I1? Yes, that's all in I1. After a lot of practice, what you can do is you can simply go from here to here, right? This is nothing but dt upon root t, so that becomes 2 root t, and therefore this. Okay, those steps can be done orally as well after practice, lot of practice. I2 over here. By the way, right now I have written all the steps, all the required steps except for one, that is x square minus 9x plus 20 has been taken as t, right? The derivative should be there in the numerator because that's what we have done, that's what we begin with, that's what we planned for, right? Okay, I2 is this expression. So for I2, I need to make this into a perfect square, right? So instead of finding I2 first, what I'll do is I'll begin with that x square minus 9x plus 20 and convert it into a perfect square. This is x minus 9 by 2 square, x minus half of 9, which is 9 by 2 square, and this 9 by 2 square has to be subtracted, that becomes minus 81 upon 4 plus 20, okay, and this is equal to x minus 9 by 2 squared plus 80 minus 81 is minus 1 by 4. This is what I get. This is what I get. X minus 9 by 2 square and minus 1 by 4 is what I get. 1 by 4 is square of 1 by 2. Yes, that's okay. But once I have converted this, therefore I can write I2. I can write I2 now. I2 is equal to what? Integral of dx upon square root of this expression, which is this. X minus 9 by 2 square and minus 1 by 2 square over here. Yes, and this is nothing but under root of x square minus a square. The formula says this will be log modulus of x minus 9 by 2 plus under root of this whole expression, which is equal to this modulus plus constant of integration c2. This is I2 for us, right? Once you have found I1 and I2, now I can write the value of I. Therefore, I is equal to what? This is equal to 3 times I1. 3 times this, which becomes 6 times under root of x square minus 9x plus 20, okay, and plus 34 times I2, 34 times this, 34 times log of modulus x minus 9 by 2 plus under root of this whole expression, which is x square minus 9x plus 20, the modulus along with that, and I1 has constant C1, I2 has constant C2, they will combine together to give C. That's what we have, right? 3C1, 34C2 will combine together to give this C, and that's the final answer for this 19th question, as we can see over here. That's all? Yes, that's all in this 19th question. The 28th question has x plus 2 upon under root of 4x minus x square. How do we handle this one? Okay, this x plus 2 is a linear term, can be written as a times the derivative of this. What is that? The derivative of minus x square is minus 2x, 4x is 4. This is what you have, right? Derivative of this is this, and plus another constant. Comparing 1 is equal to minus 2a, that tells me, okay, a will be equal to minus 1 by 2. Comparing the coefficient of x and comparing the constant term, 2 is equal to 4a plus b. What does that give me? B is equal to 4a will be 4 into minus 1 by 2, which is minus 2. That goes over there, becomes 4. B is equal to 4. Okay, so integral I will be equal to what? A minus 1 by 2 times integral of this minus 2x plus 4 upon under root of 4x minus x square is what I have. 4x minus x square dx and plus 4 times the other integral, which is dx upon under root of 4x minus x square. This is what I have, right? This is what we have, and this can be done as minus 1 by 2 I1 plus 4 times I2, where we need to find I1 and I2. We need to find I1 and I2. So I1 looks pretty simple. I1 is integral of minus 2x plus 4 upon under root of 4x minus x square dx. What does this convert into? Please observe. Derivative is present over there. So this is actually dt upon t with the under root. Okay, and this becomes 2 square root of t plus c1. It's 2 under root of 4x minus x square plus constant 1. This is the value of I1 first of all. Next, for I2 I need to solve this one. Yes, and for that I need this. I need to complete the square of this. So 4x minus x square can be written as minus of x square minus 4x first of all, and this written as x minus half of 4 is 2 squared, okay, and subtract 2 square, that is 4. This becomes 4 minus x minus 2 square. This is what you have. 4 minus x minus 2 square, yes. And once I have written it as perfect square, this therefore I2 becomes equal to integral dx upon under root of this. 4x minus x square is this. 4 minus x minus 2 square is what I get. Right or not? Yes. This is a square minus x square form. Yes. In the under root, in the denominator, if you have a square minus x square, that converts to sine inverse x by a. Yes. So this is sine inverse x, which is x minus 2 upon a, which is 2. Okay. Plus another constant c2. Do we need any a in the front? No. Do we need the coefficient of x? Yes, we could need the coefficient of x in the denominator, but that is 1. That will not create a problem, right? So I2 has been found, yes. And therefore, I will be equal to minus 1 by 2 times this. Okay, that becomes minus 1 by 2 times 2 minus under root of 4x minus x square, okay, plus 4 times this. This is sine inverse of x minus 2 upon 2. This is what you have. The constants minus half c1 plus 4 c2 will combine to give c, and that is the required answer for this question, as you can see over here. That's the 20th question for us. Question number 21 says that you have x plus 2 upon under root of x square plus 2x plus 3. And how do we handle this one? So once again, you have linear upon root quadratic. So that linear x plus 2 can be written as a times derivative of this 2x plus 2 plus some other constant b, right? We need to find the values of a and b next. By comparing coefficient of x coefficient is 1 equals to a, okay, and the constant term 2 is equal to 2a plus b over here. This tells me, okay, a will be equal to 1 by 2, and using this a, I can find b equals 2a will be 1, will go that side, and b will be 1. Therefore, I can write the integral I as sum of two integrals, 1 by 2 times integral of this 2x plus 2 upon under root of this x square plus 2x plus 3 dx. This is one thing that I have. The next thing that I have is the term b having 1 as the coefficient, and you'll have dx upon under root of x square plus 2x plus 3. Now this integral can be called I2, this integral can be called I1. This is half of I1 plus I2. Okay, and now can I find the values of I1 and I2? Yes, I can find the values of I1 and I2. Let's find I1 first. I1 is equal to integral of 2x plus 2 upon the root of x square plus 2x plus 3 dx. Now, the important thing over here is that if this x square plus 2x plus 3 is taken as t, then that will be that into dx will be dt. So this becomes dt upon root t integral. The integral will be equal to 2 square root of t plus constant, right? And this becomes 2 under root of x square plus 2x plus 3 plus constant. Let's call this constant c1, right? This is I1, right? After that, I need to solve this I2 as well. And for solving I2, I need to write this as a perfect square. This is root quadratic, right? So x square plus 2x plus 3 can be written as x plus 1 square, x plus half of this, minus 1 plus 3, which becomes x plus 1 square plus 2, which is actually root 2 square. This is what you have, right? Okay. Once you note this much, then I2 can easily be written as integral of dx upon under root of this or this basically, which is x plus 1 whole square plus root 2 square is what I have. Okay, under root of x square plus a square in the denominator, that will convert to log modulus of, instead of x we have x plus 1 plus under root of this whole expression, which is this x square plus 2x plus 3 modulus plus another constant of integration, let's call it c2. Yeah, this is I2 for us. Okay, next the only thing that remains after this is to write the value of I in terms of I1 and I2. Therefore, I is equal to half of I1, half of this, which is under root of x square plus 2x plus 3, okay. Half C1 and this C2 will combine together to give us C. But what about I2? I2 is this term, log of modulus x plus 1 plus under root of x square plus 2x plus 3, okay, this is plus. Modulus closed plus another constant of integration, basically. That's what we have, and yes, that's the required answer for this particular question over here, as you can see clearly. This is question number 21 for us. The 22nd question says we have x plus 3 upon x square minus 2x minus 5, and how do we handle this one? So once again, linear upon quadratic can be handled by writing that linear, this is the numerator, x plus 3 as a times derivative of denominator, which is 2x minus 2 plus another constant b, right? This is what you have. So comparing the coefficient of x, 1 equals 2a gives me a equals 1 by 2, and comparing the constant term, 3 equals minus 2a plus b. What will that give me? This is minus 1, it will go over there and b will become 4. These are the values of a and b. Once we have found a and b, we can easily write the integral I in terms of this a times derivative plus b. Half of integral derivative will come over there, 2x minus 2. The numerator has been split into two parts, dx plus 4 times, that is b times integral of dx upon this expression, x square minus 2x minus 5. This is what I have. Is that okay? Yes. This is I1. Let's call this I1, and 4 times, let's call the other integral I2. Yes. And now our only task is to find I1 and I2, right? After splitting this with the help of this is the first step. After splitting, you need to find I1 and I2 separately. Let's focus on I1 first. I1 is pretty simple. Recall I1, if this is t, then this is dt. Actually, this forms a part of dt. So what you get is integral 2x minus 2 upon x square minus 2x minus 5 dx. This is what you have. And if this is t, then the numerator becomes dt. The integral will be log of mod t plus c1. This converts to log of mod x square minus 2x minus 5 plus c1. This is first integral I1. For finding this integral, we need to convert this into a perfect square. Okay, x square minus 2x minus 5 is equal to x minus 1 whole square. And you have minus 1 from here, you already have a minus 5. This converts to x minus 1 whole square minus 6. Now 6 can be written as root 6 square also. And that is something which we will be doing while finding I2. I2 is integral of dx upon this, or this basically, which is x minus 1 square minus root 6 square. Okay. And what is the integral of 1 upon x square minus a square? This is x square minus a square. Formula says 1 upon 2a log of x minus a upon x plus a in the modulus. So 1 upon 2a log modulus x minus a, which is x minus 1 minus root 6 upon x plus a, which is x minus 1 plus root 6 modulus plus another constant c2. This is I2 for us. This is I2. Observe this carefully. Yes. And therefore, I can easily write I. Now, I is equal to half of I1, half of this, log modulus x square minus 5, okay, and plus 4 by 2 root 6, which is 2 upon root 6, log modulus x minus 1 minus root 6 over x minus 1 plus root 6, and combining c1 and c2, half c1 plus 4 c2, we'll get another constant of integration c, and that is my final answer for this question over here. This is question number 22 for us. Yes. Next, let's move on to question number 23 after this. The 23rd question says 5x plus 3 upon under root of x square plus 4x plus 10. Once again, we have linear upon root, quadratic. So that linear 5x plus 3 can be written as a times 2x plus 4 plus b. A times derivative of denominator, that is quadratic in the denominator, and b. So comparing coefficients, 5 is equal to 2a, which tells me a will be equal to 5 by 2. That's the first thing that I know. What about b? So 3 will be equal to the constant term. 3 will be equal to 4a plus b. Okay, 2a is 5, 4a will be 10, 3 minus 10, which tells me b is equal to minus 7. This is what I get. Okay, b equals minus 7. After that, what next? So therefore, I, the integral I can be written as 5 by 2 times integral of a times 2x plus 4 upon under root of this whole expression, which is x square plus 4x plus 10 dx minus 7 times minus b plus b times basically dx over square root of x square plus 4x plus 10. That's the expression that we have. And this is 5 by 2 I1 minus 7 I2. We can write it as 5 by 2 I1 minus 7 I2. And now our target is to find I1 and I2 first. So let's focus on I1. Is equal to, if you observe, this is 2x plus 4 over upon 2x plus 4 upon x square plus 4x plus 10 in the under root dx. And if this is substituted as t, x square plus 4x plus 10 equals t, then in the denominator we have root t and in the numerator we will have dt. The integral will be 2 square root of t plus c, and this is 2 square root of x square plus 4x plus 10. Let's call this constant of integration c1. Instead of c, let's call this c1. Okay, what next? Next we need to solve this one. For solving this, we need to convert this into a perfect square. Yes, and this is very easy. This is x plus 2 whole square plus 6, right? So I2 can be easily written as integral of dx upon under root of x plus 2 whole square plus 6. Do you observe that? Yes, this is what you get. Okay, and this is x square plus a square root 6 whole square, right? So this will convert to log of modulus x, which is x plus 2 plus under root of this whole expression, which is x square plus 4x plus 10 modulus plus c2. That's what you have. Another constant of integration c2, right? And after this, I can write I equals 5 by 2 I1. 5 by 2 times 2 will become 5 times under root of x square plus 4x plus 10. That's one term. Minus 7 times this expression, minus 7 times log modulus x plus 2 plus under root of x square plus 4x plus 10, and this plus constant of integration c. That's my answer for this 23rd question over here, as you can see clearly. Right? That's the complete solution and final answer for this 23rd question. Question number 24 says that integrate dx upon x square plus 2x plus 2. And what is this equal to? Looks pretty simple. X square plus 2x plus 2 I equals dx upon, this is actually x plus 1 square plus 1. Yes, and this will directly convert to tan inverse. This is simply equal to tan inverse of linear expression. Yeah, so this is x plus 1 upon 1. At max you would have had a 1 in the front, so this is simply equal to this tan inverse of x plus 1. Actually the correct answer, as you can see, is option B. That's pretty simple. Yes, pretty simple to solve this one. This is option B for us. The 25th question says we have to integrate dx upon 9x minus 4x square. Now how do we handle this? So 9x minus 4x square has to be written as a perfect square first of all. So 9x minus 4x square can be written as, okay, let's take out a minus 4 common, x square minus 9 by 4x. This minus 4 is okay. This becomes x minus 9 by 8 square, one thing, right? And we have to subtract the square of this 9 by 8. What is that? 81 by 64 is what I get. Okay, let's take this minus 4 inside. Minus 4 times x minus 9 by 8 square is what I'll get. Yes, okay, and what else? Minus 4. Okay, let's not take this minus 4 inside for now. Let's only take the minus inside. Okay, let's keep that 4 outside, and what do we have? This minus goes inside and this becomes 81 upon 64 over here. This is what you have, right? So in the under root, I will be equal to integral of dx upon under root of this whole thing. Under root of 4 is 1 by 2, which will come outside, yes. And under root of this whole thing will be, this is 9 by 8 square minus x minus 9 by 8 square. This is what I have. Right or not? Yes. Okay, and what else? What else? Once you have written this properly, the next thing that you can observe is the integral will be in terms of sine inverse. Yes. So a square minus x square in the under root, the integral will be sine inverse x by a. This 1 by 2 remains outside and sine inverse x by a. So x minus 9 by 8 upon 9 by 8. What is that? 8x minus 9 upon 9 is what I will be getting, and plus a constant of integration will be there. This is what I get. So 1 by 2 sine inverse 8x minus 9 upon 9, 1 by 2. This is 8x minus 9. The correct answer is option B, as you can see along with this over here. This is the 25th question for us, and yes, that's a complete solution. We have solved this particular question. We have solved 1 upon quadratic, 1 upon root quadratic, and linear upon quadratic, linear upon root quadratic over here. That's all in this particular exercise. Till the next session, all the best.